All right, the last speaker between you and lunch. No, nobody's favorite place to be. I will try to be prompt. So I think, as probably many of you are aware, the US EPA and the Bureau of Land Management are both evaluating potential new methane rules that would have a leak detection and repair component to them. So over the summer, we were thinking about what advice we would give these agencies about how to form an effective LDAR program, and decided to pull the data from all of the different programs that we have across different states in the US. The Colorado program, as Stephanie pointed out, is quite new, so our data was fairly limited. But we do have some programs that have been running for a decade or longer, and we have programs that range everything from heavy oil facilities that are over 100 years old to dry gas facilities that are much newer. So we thought we had a pretty robust data set to try and look at and see if we could pick up any trends. And our programs encompass a bunch of different technologies. You've heard about them a couple of times today now. And our friends from WPX have actually both of these two tools out there for you to look at. They don't let me travel with 100 grand worth of equipment and cool toys to look at, so I'm excited that they have them out there for you. The top is a picture of a handheld sniffer, so those can be PIDs or FIDs, but the advantages of this tool is it's relatively low cost. So while an IR camera might be around $100,000, these are somewhere between $5,000 and $10,000. So it's easier to have a bunch of these. They also require a lot less training. And the disadvantages are that an individual has to go from component to component to component on site and place the little probe on top of it. So it's more labor intensive. And just as a fun aside, one time they did let me out to play with the toys. And this is a sniffer actually out just in the Four Corners area south of Durango in the middle of a dirt road. And you probably can't see it from where you are, but it is showing 500 ppm. So if this was on the Colorado side of the border, this would have been an official leak. It was in the middle of a dirt road near a natural seep. And the lower photo there is an optical gas imager, and they've got one of those out there. The advantage of this type of equipment is that you can scan a wide area pretty quickly. So standing in one place, you can see, that picture may have 20,000 components in it, and you can see all of them without having to go component by component by component. The disadvantage of this tool is these cameras are a lot more expensive. They're around $100,000. They require training. They're a lot more, maybe 2-3 weeks of training in a classroom type setting, but also an awful lot of field training to get really good at being able to differentiate the temperature in the background. Other disadvantage is it's not going to give you a ppm, so you don't know what the concentration of the leak is. And I should note that for both of these technologies, it doesn't really characterize the flow. So you don't know, it's not like touching a flow meter to the leak where you can really quantify how much methane you're capturing. And then the bottom category is emerging technologies. And just like emerging technologies with cell phones or anything else, they promise to be better, faster, cheaper. There are a lot of technologies that are offering constant monitoring, quantification, wide area monitoring. And there's a lot of promise here. We're very excited about it at Chevron. We've tested several of these technologies in the field, so we think that they're a couple of years out. These are not decades away. However, they're not quite there yet. So in addition to looking at the different types of equipment and trying to figure out what we thought worked best, we also looked at what kinds of sites we're likely to find leaks on. So what we found is a well pad without a compressor was very infrequently you'd find a leak. When you look at sites with compressors, you're more likely to find leaks, but it's still pretty infrequent. So what we recommend to our business units for their programs is they survey all sites with compressors, and that includes tanks with vapor recovery units, using any of the methods appropriate for their operation, and they do so annually. We haven't seen a benefit for any programs that are greater than annually. Someone mentioned the very poorly named KKK subpart program. And that program is a bit more frequent, but when you're in a big gas processing facility, it's a little bit of a different situation. You've got a confined place, you've got a lot of moving parts. So in that case, it makes a bit more sense. But in a field situation, we couldn't see it in places where it made sense. So what we found that 0.05% of our components are leaking on a repeat inspection. So if you think about that, that's 1 in every 2,000 components. Somewhere between 70 and 80% of the sites we go to, we find no leaks whatsoever. And this percentage is actually pretty consistent amongst old operations, new operations, IR camera, method 21, doesn't change a whole lot. The only difference is between that initial survey, where you see a rate of somewhere around 0.15%. So to put this in a little bit of context, in the Colorado rulemaking and in the EPA rulemaking and the BLM rulemaking, they're estimating that 1.18% of components will be found to be leaking when they're on these sites. So it's orders of magnitude difference between what the best estimates are there and what we're actually finding in our programs. And this was, I have to say, a pretty startling finding for us. We have our operations all doing the right thing and doing their programs, but we had never actually pulled it up to a higher level to look at it. And we were very surprised to see how low of a number we were sort of settling out at in these programs. So what we've learned is that basing your survey program on risk is the most effective way to make it, the most cost-effective way to structure it. So our program has an average cost effectiveness of about $1 million per ton of methane recovered. So not terribly cost effective, we're working on making it better. But the more regulated the programs become, the less flexibility you have to customize it, so that's probably about where it's gonna stay at about $1 million per ton. Rotating equipment is most likely to leak, so it's really important that you're looking at all your sites with compressors. OGI and so your optical gas imager camera and your sniffers have pros and they have cons. So we think it's important to make sure that all of those are an option. Colorado has done a great job of that. The draft EPA and BLM rules at this point don't provide that sort of flexibility that Colorado has provided. We also think it's really important, as Colorado has done, and Steph, I was really excited to hear that there's a couple of companies that have applied to have new technologies listed, but the way Colorado's program is structured is that you can apply to, you don't have to reopen the rule to create and to allow a new technology in. The district has an approval process that doesn't require a whole new rulemaking. We think that's a really good way to go about it, and we hope that EPA and BLM will also take that approach. So as these new technologies come on the market, we have the ability, without opening a big, massive rulemaking, to do something that's cheaper, faster, and more effective. And most importantly, if you have to do a bunch of these surveys when you're not finding leaks, it's really costly and not helping the environment and not helping operators. We don't want to have leaks. It's certainly not in our best interest, but it's also not in anybody's best interest to keep doing inspections when you're not finding anything. In conclusion, LDAR is a very powerful tool. We as a company do it in areas that we're not required to do it. But it's really important that it's applied flexibly in a risk-based manner. There is no one-size-fits-all oil field. There's no one-size-fits-all LDAR program. And we're very excited about the promise of the new tools that will be hitting the market very soon, and we hope that our federal regulators will take a lesson from Colorado and allow us to apply these new tools as they become commercially feasible. Thank you.